तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
In the previous lecture, I said that I will help you get an overview of software and hardware in general. By and large, we covered most of the software, the different aspects of software and families of software. And then we started with the hardware, which we will try and complete today and possibly extend. Now, whatever that the user sees, okay, these things are listed here. That is, if he opens the computer system, then he would find some CPU boards, some memory boards and some IO boards. Essentially, the IO boards are the ones which help interface the man with the machine through the devices, say keyboard through which he would be inputting, printer through which he will be getting an output, the same thing about the displays. Fine. Now, there are different types. Now, if you take keyboard for instance, the CPU will be looking from the keyboard some code, then that particular keyboard will be called an ASCII coded keyboard. There can be different types of codes. Similarly, there are different ways in which, for instance, the information can be sent through the keyboard, and accordingly the keyboard types will vary. Fine, we will not go into details. Now, if you take the second category, say printer, again there are different types. Say there will be a dot matrix printer, there will be a laser printer, there may be a daisy wheel printer, there may be an inkjet printer. Now, obviously you can see you have different devices here, and given a particular device there are different types. So, what exactly the CPU will be looking at this end, the bus end, that must be standardized. Otherwise, we cannot have a set of standard signals and set of signal lines here and a specific protocol. Okay. So, this IO is essentially an interface, and that particular interface will have to act like a buffer between the specific device, whatever may be the type, and the standard bus. Okay. This is very important, right. Now, for instance, if you take dot matrix printer, the information that will be sent, for instance, can be as low as one dot or one point. Even a particular say a letter or a character, okay, in English can be formed with 5 by 7 matrix, that is why it is called dot, okay, 5 by 7 dots forming a matrix. Whereas, when you take daisy wheel, right, the particular character will be printed directly. That is, we will be dealing with the information about a character at the character level here, whereas here we will be dealing with the information related to a character at a lower level. So, these variations will have to be taken care of, and that will be done at the interface level, right. Similarly, other things, now laser printer is there, inkjet printer is there. So, all the information on this side will have to be buffered, and on this side there must be some standardization. Okay. Fine. Now, if you take displays, okay, the next one, the most popular one is a raster scan, and that is what we have even in TV. Okay. What is a raster scan? If you take the screen, the display is formed with scanning across the screen in this particular manner, right, that is from one end to another, and the time taken for this particular beam to move from this to this one end to the other end will be about 52 microseconds, and then for it to go back will be 12 microseconds. Okay. Now, within this 52 microsecond, one line of information, it may even correspond to one dot. Okay. That particular thing will be scanned. Now, in contrast with raster scan, you have other types, or in fact all these belong to the same family. Sometimes they, or even we may say same or similar. Okay. Random scan is one, that is, you are not forming pattern like this from left to right across the screen. Randomly you can create a point here and at another point here, another point here, another point here, and so on. Okay, that is random, as in fact the very word random is coming, because randomly it can be, and then it is in contrast with the raster. Okay, this one is called a raster. Okay, the same thing with point plot, same thing, just plot one particular point at a particular time. Now, the way the information must be fed to the display in this and this particular thing will be different. Okay. So, these things will have to be taken care of. Now, CPU may be sending just one character, let us say A, and that particular A will have to be displayed in different ways depending upon the types of display. Okay. Now, on this side we should not bother about that, it must be something uniform. Okay. We will talk more about this later. Now, on this side you see that there are variations, the same thing, random scan or point plot or calligraphic or vector displays, they all almost are similar. Good. That means now you can see that if you take an I/O interface, well, actually I have not indicated a few other things, maybe I will come back to this again, right. So, just for the present note that there are lot of variations here. The same thing about these also, if you take a CPU board, right, depending on the application, the CPU board, the characteristic of the CPU board may vary. Earlier we have said that we have a wide range, that is, at one end we have control applications and at the other end we have data processing application, right. That is what we started with. Now, the system that is meant for control applications will be having one type of CPU board. For instance, in control it may not always be just processing the data or carrying out some computation with reference to the say numbers. The input may also be coming in the form of analog signals. Okay. So, the CPU board will have to also deal with analog circuits. The analog signals may also be coming from different places, let us say in a process control application, in which case the signals must be conditioned, sent, digitized, and subsequently only it will be processed. So, the type of CPU board you have for control applications will be different from pure data processing applications. Okay. That is one thing. We can go on talking about this, but not at this stage. Now, if you just take memory, for instance, memory boards. Okay. These memory boards, again there will be different types of memory boards. Why? The main thing in this is the speed with which a particular memory responds to a request from the CPU. Okay. The speed with which a particular memory responds to this request from CPU. You remember what I said earlier, essentially CPU will be the master, that is, usually the CPU will be the master of this bus. As a master, it will request memory and the memory will respond, let us say with data, maybe instruction, whatever it is. Okay. The speed with which it response, that is important. Now, the higher and higher speed of the memory is going to be costlier, right, and the more costly a particular memory is, obviously if you want to see that the system should not be too cost, you are not going to have too much of that. That means the size. So, really starting with speed you can just see the cost part of it, okay, that also changes, and similarly the size. Okay, they are all sort of interrelated. The whole thing starts with the speed. Now, normally CPU is very fast and memory also made up of electronic circuits, and so normally we may say CPU and memory interact at electronic speed, and that is not the case with I/O. I/O usually will be slow, not always. For instance, if you take this display, it is going to be very fast really. Okay. not always, but most of the IO devices will be slow. Okay? Fine. Now, the CPU requests memory, and then here we may be having memory of different categories, right. So, we may talk even about memory hierarchy here, it is in fact, go back to that original one in which we are saying that the core of a computer system is the hardware, right. Now, the core of the hardware will be the CPU. Now, the CPU deals with some memory which is I mean the particular memory which can respond at the as fast as CPU, right. That whatever the CPU wants, it will do at that particular rate. So, the fastest memory will be here, and then you will be having the slowest memory away from it, and then further slower ones outside, like this you can have. That means, basically the fastest speed will the higher speed memory will be here. Now, that one generally is called a cache memory. The one that is not so fast, but fast enough, okay, these things are generally called DRAMs. I will later on I will give you some information about this, how it came about. In fact, it is because of the technology, okay, and this is because of the position in which it is. This is how the name had come about. Now, this DRAM or dynamic RAM, okay, this generally is called a main memory, okay, it's main memory. Earlier in those days, this was called a core memory, because that was the main, core is always the main. Then the one outer than this, okay, this generally is called a secondary, it used to be called secondary memory. Now, these days generally we have the term storage reserved for this particular one. Secondary storage, usually this is consisting of some magnetic devices, say disks, okay, this may be tape or whatever it is. Now, if you work out the cost part of it, usually which is indicated what is the cost per bit of storage. What is bit? Binary digit, okay, 1 bit, 0 or 1, cost per bit will be indicated. The cost per bit will be the highest here and the lowest here. Now, how about outside of this? Outside all this also we have, what is it actually? It is in fact what I may call as the real world, and the data may be coming from the real world, okay, through appropriate transducers, and for instance, in control applications, that is what you will be having, right. Through transducers, analog signals will be coming, that information also can come from here. Now, there are many ways in which you can organize the data. You can collect the data, put them here or here or here, and let the CPU access. This is one way. The other thing is the CPU, because of some reasons, may access the data directly from the real world also. That is why we say these things generally when we talk about the IO or input output, well, even the user is very much in this real world, is it not? And essentially what he is doing is, he is going to make use of the devices and provide the input output. So, he is also providing the data, and the data can also come from the memory, right. So, essentially memory is what you have, this also is secondary memory or secondary storage. Okay. So, now of late main and secondary are dropped. Memory means essentially this particular layer, storage means this particular layer, though okay, memory also stores, what is in store is also available as memory, right. Okay. That is the term, fine. This is going to be let us put it this way, the cache memory is going to respond to the CPU at the same speed as the CPU, right. The response of the DRAM is going to be slower than that, and then this particular one further slower, and then in the real world it is really dead slow. Okay. Quite often that is what it is. So, we can think in terms of this. When you go out, what we have is say decreasing speed, right. When you go out, you have decreasing speed right here. Decreasing speed, and also the same thing as decreasing cost. And because of decreasing cost, what you have is increasing size. So, you would find that the size of the costliest cache will be less and the size of the cheapest, okay, or inexpensive, this particular storage will be more. So, let us say, so we can think in terms of this, that is the cost part of it, the size part of it. Cost I will not discuss because it will keep varying, and then the speed part of it. Okay. A typical figure you can have, say cache, and then the DRAM or the main memory, and then the storage. Okay. It is only typical, it is nothing much about. It will vary from time to time. Okay. Maybe you can take it given a particular time. The speed of this, let us say, is around say 10 nanoseconds. Okay. That is, in 10 nanoseconds, the information, the data, one unit of data that the CPU wants can be made available, whereas here this particular one may be about 100 nanoseconds, and that usually is in milliseconds, say some 2 to 10 milliseconds. Right. The cost of it varies, so I am not going to very much bother about that. The size of this usually in kilobytes, say 1 kilobyte, 4 kilobytes, sometimes even up to 64 kilobytes. Okay, kilobytes. DRAM will be in order of megabytes. So, one talks about say 8 megabytes, 16 or 32 megabytes, and storage will be hundreds of megabytes. Okay. Say gigabyte even of that order, hundreds of megabyte. So, that is what you find. So, the memory hierarchy part of it is such that the CPU essentially will be looking for data in cache, because that is where it is a fast, it is very fast, and so the data will be available as soon as CPU wants, otherwise the CPU will have to wait. Whenever the CPU waits and does not proceed, obviously it becomes inefficient. That means, we say the processor is not being well utilized. Now, in case it is the required data is not available, this will be loaded from DRAM, assuming it is available there. In case that is not available there, then it will be loaded from this particular one. Okay. Now, you may ask, what does the processor or CPU do in case some information is getting loaded from here to here? CPU may be waiting, or it may be taking up some other program and carrying it out. The same thing about this. Now, if data is not at all available anywhere here, obviously the required data is not available in CPU, and so it will have to be loaded subsequently from the real world. Okay. Now, that is about the memory hierarchy part of it. There are other things also we can talk about the memory, that in fact what I will call as based on technology or technology driven classification. Okay. For instance, I have already talked about this. For instance, see the D, okay, DRAM, D stands actually for dynamic, okay, dynamic RAM, and as you may have guessed, there is another type called static RAM. Instantly, static RAM will be faster than dynamic. So, invariably you will find cache memory consisting of static RAM chips, okay, that is the technology part of it, and dynamic RAM is slow. So, that is what it is called DRAMs, though essentially it is that is the memory part of it. Well, there are other things also one can talk about here. Okay. I will not go too much into the technology as of now. Fine. We are talking about the memory. At the same time, let us not forget about certain aspects of the storage also. Storage, as I said, essentially is for storing the information, right, and that is in fact the most inexpensive one, and it was the outer layer. And we are all familiar with the floppy diskette, that is a floppy subsystem in which the media will be the floppy diskette, and the hard disk subsystem in which the media is the hard disk. Okay. We are all familiar with that mostly. We will not talk about more about this, except noting one important thing here. Though we generally say storage, do not forget that they not only store data, but the same thing can also be used for input output. Fine. The files can be stored there for providing the input, and the same way the output of the system can be stored in the form of a file and kept here. So, storage is also for I/O, though it is not really in fact it will be coming under this particular one. Like in the case of the other devices, in the case of storage also we would need the appropriate interface. Now, for the floppy subsystem there will be one type of interface, for the hard disk subsystem there is another type of interface, right, that is what it is. Now, few points about this I/O. Now, talking about the I/O, a few points are this. Let us see, you already noticed that the devices that are there, whether it is for storage or I/O, they have different characteristics. So, obviously, the interface circuitry that is needed here, what will it consist of? Normally, let us see, here we have this bus, I will just redraw this again, have the bus here, and then the I/O port is essentially providing the interface, okay, the interface, and is what you have for a specific device, and then we have the device. Let us say for instance, if we have a disk subsystem, okay, I will just call it system, generally the computing system, that will be the subsystem. Now, what exactly does this interface consist of? Now, many of you may have noticed that in the case of hard disk subsystem or floppy diskette subsystem, you always have some moving element thing, that is the media itself will be rotating around, and then there may be an arm going over it. That means, essentially these are electromechanical devices, right. Good. That is, the interface circuitry part of it will consist of two things. What are they? The interface circuitry part of it, one will be what you may call as device electronics part. This in fact has nothing much to do with the data that is going to be transferred over the at this end. The device electronics part of it is essentially for taking care of the specific requirements of this device. Okay. Then you have the other one, which generally called a device controller or just a controller, the controller part of it. Whenever we discuss a computing system and then the interaction, it is this particular one which we will be concerned with, not this particular one. Now, for instance, the device electronics will include the appropriate circuitry for rotating the motor, for moving the arms, all those things, okay, and for positioning the reading head over a specific place on the media, whether it is disk or diskette, all these things. We will not talk about that. That is, from the when we discuss the bus point, we will not bother very much about it. We will more worry about this controller part. This controller is the one which is going to collect the data, okay, from here, from the input output, and pass on to the bus side, okay, from here to the bus side, it will be passing it on. Now, this side must be uniform, because we are stating that if you do not have a uniform set of signals here, we cannot have a standard bus. So, the diskette controller, the disk controller, or let us say a keyboard controller or a printer controller, whatever it may be, that particular one has to see a uniform thing on this side and then take care of the specific characteristics of the respective devices on this side, right. Okay. So, the controller part of it is what we are saying, and recall, remember I was telling as part of operating system there will be IO routines, remember as part of any operating system, earlier I was mentioning there will be IO routines. Now, I also mentioned that these IO routines are standard and part of the system, that is one user need not keep developing. Given a particular device, the routine will be there and any user can make use of it. As part of that IO routine, you would also find the software aspect. Generally, that particular thing is called a device driver. Okay, a device driver, which essentially is the software associated. Of course, it will be running as part of the operating system. Okay, it will be there will be one device driver for each say disk subsystem or any of these, any of the device in fact. That means, we have, as far as the IO interface is concerned, we have the device electronics to take care of the movement of heads etc. for that particular device. Then we have the device controller which will take care of the bus standards and pass on the information, and as part of the operating system there will also be device driver. By the name driver, do not think it is anything hardware, it is pure software part of it. Now, that is one important thing. In fact, we may say that this particular device driver is the highest level of the software for the in the operating system for that particular device. That means, one device driver for each device, this okay, good. And here again there will be a set of commands and the actual user need know only about those commands while dealing with that device. Good. That in fact sort of summarizes the hardware part of it. Now, we will just take a look at two other things. Whenever we talk about computer system in general, right, of late we talk about two things. One is the standalone computers. Standalone computers, by that what we mean is a computer which is there and that is a computing system, let us say a desktop computing system which has its CPU, memory and IO cards and all those things necessary for a particular user. So, generally what we have here is a single user in mind, okay, single user in mind, that is what you have when you have a standalone. In contrast to this, because of the technology advances, now we also talk about networked computers, okay, networked computers. Now, here again the networking is there and then you also have these independent systems, but then the independent users can communicate over this. There are other aspects also, I will just presently tell you what they are. Okay. So, using standalone computers and having the extra thing of networking, then we talk about the overall system as a network computing system. Now, what are the various purposes of networking? Number one, as anyone can guess, first it is to establish communication, that is among the users. There may be different reasons for this. Let us say in a typical office, okay, the officer may be having one system on his desk, the secretary may be having one system on the desk, right, and then there may be other people and we essentially establish communication among these. Now, in a typical design office, Okay. The manager will be technical manager will be having this thing, and then there may be some 3 or 4 different design teams, maybe a hardware design team, software design team. Given hardware design team, there may be circuit designers, there will be PCB designers, like this. Okay. So, having networked system, you can see that communication among these I would say batchmates in a given batch okay, among the team, that particular thing can be established, communication among them can be established. The other reason for that network computers is basically to share resources. Okay. What are the resources we are talking about here? It is possible that some of these say devices may be very costly. Let us just say, supposing we have a printer and its dot-matic printers are fairly inexpensive. Suppose you go for very costly printers, let us say laser printer. Okay, even laser printers these days are not very costly. Okay, assuming it is costly, suddenly it is costlier than dot-matrix printer. Suppose there is one laser printer, you do not need a laser printer on each desk, like you have a computer on each desk, right. So, among the people, that is among the group of people, right, you can have this particular thing shared by that, let us say the laser printer shared by others. Now, you also talk about other things like for instance file servers, okay, that is all the files are available in a particular system, and that would that can be accessed by other users. Now, this is another thing. Generally these resources are shared for 2 reasons. One is the data is available in common and it can be used by others, and second thing is you may be having very expensive things and you cannot afford to have one for each user. So, this is thing. The third is basically for remote access. What is this remote access business? It is, suppose my system with its local information in some hard disk or so is available elsewhere, and through the over the network I can remotely log into my system and then access the data. Okay, that is the third aspect of it. Here actually it is very much like having an independent system of your own, but physically you are not in the place where the system is. Okay. So, making use of the network part of it, you remotely access your system. So, that in essence the set of reasons for networking of computers, and in fact for instance these days, you remember I was mentioning about multimedia computers earlier, right. Now, one typical use of a multimedia computer is for video conferencing, right. That is, the conference sites are geographically distributed in many places, and then let us say there is a conference or a meeting arranged, right, a conference or a meeting arranged, and a person, let us say some 4 people are participating from 4 different cities. A person can raise a question, that is the audio part of it, it goes to the different places, and in response to this from another place another person is, let us say, showing a video clip, and that again goes on, okay, goes to all the places. And while watching a video, for instance, simultaneously from 2 different places 2 different users may raise some question, which means 2 audio files are being generated in 2 different places. Okay. Now, as of now we need very high speed networks to support such things, but I am just talking about a typical application, and of course, this soon such applications we will be finding them in use. Okay. I hope by now you have got an overview of a computing system, and then specifically some aspects of software and hardware. In fact, we can go on talking about it. As you may have noticed, I was just mentioning the term bus, I have not gone into the details of it. In fact, there is more to it. Well, we will possibly take up this later on. Now, essentially you would have observed by now that CPU, memory and I/O. Now, if I leave I/O as extended memory, we have only CPU and memory, right, these two things. Now, what we have in a computing system is the CPU and the memory, right. So, these are the two things, and as I said, I/O is extended memory. So, we will just take it as part of that. Good. The CPU as master is going to demand something, right, or ask memory for something, and memory will respond to that. Okay. Precisely, that is what we have. That is why we said CPU is usually the master and memory is usually the slave. So, for us to get an idea about what in fact goes into the CPU and then later on also take what goes into the memory subsystem, we should really know how exactly the interactions will be going on. Good. What does it ask and how does it ask, and then how the memory responds. Now, these are the things we will keep seeing in detail. Good. For the present, I will say that the CPU will ask memory as per some specific procedure. Now, assuming the memory is organized in such a way, okay, some organization I will assume, let us say some slots are there in the memory, then into this slot the data or instructions will be entered, the instructions of CPU. In fact, what we are talking about is CPU ultimately is going to execute a program, and the program essentially consists of instructions and data. Okay. We may also use the term operand for data sometimes, right. Good. So, this is what the CPU will be asking. Assuming the program is there as per some organization internally, the CPU will be either asking for the instruction, the memory will be responding by passing on the instruction, or later CPU may be asking the memory for the data or the operands, in which case the memory will be responding with that. Now, here it is arranged in such a way that we may take one of these and then say each part of this memory such as this, you may call them as locations, okay, location, and each one of them is a location, and you can assign a specific address to that particular location, which means this address is unique for this location. Well, it is a very common sense approach, right. In fact, I always hold the view that CS not only stands for computer science, but it also stands for common sense. For everything that you find in computer science, you can always find a common sense thing to that. Now, it is something like a street consisting of houses, and each house has a specific address. Yeah, good. The same thing here too. So, we may say now the CPU, when it asks the memory, is going to pass on an address, and in that particular specific location, let us say there is some instruction, and that instruction will be passed on as part of response to the CPU by the memory. So, essentially this is what is going on, because a program will consist of instructions which the CPU is capable of executing, and it will also include the data which the user wants to be processed on. Okay, that is what it is. Good. In other words, essentially you have two major phases of operation by the CPU. What is that? The two major phases are, one is fetch the instruction, whatever the particular instruction is, fetch that, this is one phase of it. The other phase of it is execute that instruction. Okay. So, in this fetch execute phases, right, one particular instruction will be fetched and it will be executed. What that instruction is, what execution is really depends on what that instruction is. For instance, you may have an arithmetic instruction, let us say add. Okay. Suppose the instruction is for addition, then the data, minimum 2 data will have to be passed on, A and B, right. So, during the execute phase, the data A and B will also be fetched from the memory, because we assume that it would have been stored earlier in the memory, and these will be also fetched to the processor, and remember it is the processor which is going to execute. Memory will only be responding with either instruction or data. So, when we talk about fetch, essentially what we are talking about is instruction fetch, okay, and fetching an instruction is always the first thing to do, right. After it fetches the instruction, then as part of execute phase, the data will be fetched, okay, 1 or 2 or more, and then the actual operation will be also carried out, right. So, instruction fetch and execute that instruction, and as I said, as part of execution of the instruction there may be data fetch or operand fetch also. So, this whole thing is called an instruction cycle. Now, precisely that is what the CPU always keeps doing, that is the instruction cycle consisting of a fetch cycle and execute cycle. Now, how does it go about? Let us see. The CPU will be placing the address of instruction on the bus, okay, we can recall on the bus, and the memory will respond by putting the contents of that particular address, which in this case is instruction on the bus. CPU will get that. That is part of the instruction fetch phase. Then the particular instruction which has gone into the CPU will have to be interpreted. So, usually the interpretation will also be done, okay, before the execution comes. So, we may say fetch, interpret, sometimes you have a different name for that, that is let us say decode, okay, decode, and then execute. This is what you have essentially in any instruction cycle. Now, really we are not bothered very much about this interpretation or decoding, for the simple reason it is not going to take much time, that is why. Whereas, the fetching of instruction and execution will take more time, more of CPU time. The decoding of it will be done almost instantaneously, okay, or it takes much less time, but nevertheless it is very much part of it. So, an instruction is fetched from the memory, it is interpreted or decoded. Why do we say decode? Because the instruction that comes, okay, that particular thing itself is in a coded form. So, that code will have to be understood, and that particular code will be unique to that particular processor, no. So, that is why it is called decoding, and interpretation is basically understanding what that instruction says, that is what it is. So, fetch the instruction, understand what that instruction is or decode that particular code, and then execute, fine. So, this is what it is. Now, as part of the execution I already mentioned, operand may have to be fetched, because essentially program consists of instructions and operands or data. So, as part of the execute, similarly again data fetch may be there, and after the data is fetched from the memory, because maybe the data is in another place, in which case the data required for the particular instruction may be in another place in the memory, in which case the CPU will have to place the address of that location and the memory will pass on this data to the processor. Now, after the processor gets both the instruction and the required data 1 or 2 or 3 whatever it is, it depends on the instruction, then it's really will be executing, or we may say it's going to process the data. Okay. So, that is one instruction cycle. Now, this understanding of this is very very basic and very important, because again and again and again in this particular series of lectures I will be talking about this instruction cycle. Now, having understood this, that is, we have an instruction cycle which consists of fetch and execute. Okay. Now, we can see that the instruction fetch may consist of fetching possibly 1 or 2 or 3 units of information or data. That is, for instance, though marked like this, it is possible that the instruction is occupying more than one location, in which case if this is the unit of data that the memory can always put on the bus or the CPU is capable of getting, then assuming the instruction is put in 3 locations, then the CPU will have to place this address and then this address and then this address. So, that is what I have indicated here. It so happened I am just assuming the instruction is fetched in 3 phases. Okay. Now, every time what does it do? The CPU addresses, and for addressing and getting the response, that is the data, remember one thing, whenever I say data, it is not always only the data which we mean by operand. It may also, whatever the memory contains will be called data. For instance, instruction also is referring as data. Okay. So, be careful whenever we use the term. It is so in almost all the books also, for instance. So, the CPU asks for some data and it is passed on. The first thing it will be asking for will be the instruction, that is one form of data. Good. Now, we find that the instruction has come in 3 steps, and then similarly possibly that particular instruction may need again to access the memory thrice, just assuming. So, each time what is happening here is fetching 1 unit of information from the memory. Now, this particular one takes place over the bus, and so we can say that in this particular one there is a bus activity that has been initiated and it will be concluded. So, we may say that in this particular duration the CPU initiates a data transfer by addressing memory, and the memory passes on 1 unit of information or data, whatever you call, in this particular case 1 part of instruction, and this particular one is called, when the bus activity takes place, this particular one is called a machine cycle. That is, during one machine cycle, which is part of the overall instruction cycle, right. The overall is the instruction cycle, and instruction cycle for instruction. In this particular part, the CPU has placed and got some information, right, and then each of this again can be split. Now, I will just take any one of this, it is true for any of this also. Some minor activities will be going on, right. Now, I am just showing as if that there are 4 activities, minor activities going on in this. These are some small steps in the entire machine cycle. Given a machine cycle, some small steps of activity again. What is that? That to understand that particular one, we really have to go into the details of the processor, which is what we will be shortly doing. Now, we can summarize that essentially the program is executed by taking instruction after instruction. The instruction cycle consists of machine cycles, and in each machine cycle there is some bus activity, and each machine cycle consists of some small steps of activity, right. Now, specifically each one is called a state of the processor.